So in today's video we're going over one of those more basic integration techniques, especially if you're in like AB calculus. So this integration technique is integration by long division, and it will normally work with rational functions. So a rational function, so let's call it r of x, is going to be the same thing as p of x divided by q of x, where p of x and q of x are both polynomials, and that is a rational function. Integration by long division is useful whenever the degree of the numerator, so p of x has a degree higher than the degree of q of x. But don't worry, I'm not going to try and stump you throughout this. So what long division really is, if my pen wants to work, is we're going to be turning this rational function r of x, which is in the form of p of x divided by q of x, into a polynomial, which we'll call s of x, plus a, hopefully it's just a constant, but sometimes it doesn't work out to be just a constant, and that's okay. So let's actually call this z of x, because it can be a polynomial in theory, divided by q of x. But z of x needs to be a degree lower. Degree is lower than the denominator. So let's try working out some of these rational or these integration problems and see how we actually will evaluate these integrals using long division. For this first integral, we're actually not going to use long division. We're going to use another technique of integration that's very similar to long division. So this technique is known as synthetic division. So we're going to solve x here for where it's equal to 0. In this case, it's just 1. And we're going to put that in this corner. We're then going to be putting the row of the coefficients of the x values, going from like the highest value, then the second highest, and the third highest, and then the fourth highest powers of x. And we're then going to kind of subtract it. I'll show you what I mean by that. So we have the coefficient of the highest degree of x here, which is 1. We'll put that there. Then we have the next highest power of x, which is x squared. We don't actually have an x squared, so that's just 0. Then we have a 2x, and then we have a 1. Alright, so what synthetic division is going to do is we're going to drop down this first value. It's 1. Then we will multiply this value by this number over here, which is also 1. Now we have to sum up the row. So this is going to become 0 plus 1, which is 1. Then we then we move this over to the next row, which becomes 2 plus 1, which is 3. Now you bring this 3 up to the next row. Now it becomes 1 plus 3, which is 4. Now you might be asking, what do these numbers mean? These are our coefficients for x values. So this is really x squared. This is x. This is just the constant at the end. And this 4x is actually just going to be the remainder. So this has become the function x squared plus 1x plus 3 plus 4 divided by x minus 1. Now this function right here is a lot easier to integrate. We can integrate this last portion using u substitution. So whenever we integrate this, we'll get x cubed divided by 3 plus x squared divided by 2 plus 3x plus 4, and we're going to say u is just going to be x minus 1, so then our du is just going to be dx. So I'm just going to say this is the same thing as the integral of 1 over u du, which is equal to the natural log of absolute value of u. So, and we know what the natural log of absolute value of, or we know what u is, which is x minus 1. So finally, we can plug in plus 4 natural log of the absolute value of x minus 1 plus the constant of integration c. And that's the answer for this integral. This next integral, I'm not so certain it will have a nice answer to it. And in fact, we might have to just do the long division on it, and then we won't be able to do the rest, as we may not have the tools to do that, specifically partial fractions. Partial fractions. So to start out, we can't use synthetic division for this integral. So rather, instead of doing synthetic division, well, in theory we could, but we're not going to. We are going to start out with a good old-fashioned long division from algebra. We'll put this top function inside the box, x cubed. There is not an x squared term, but I'm going to treat it like there is one, plus 3x plus 2. And we're dividing this by x squared minus 4x plus 3. Alright, well, let's just worry about the highest power of x here. What do we have to multiply x squared to get a 2x cubed? And the answer to that is going to be 2x. So we're now going to subtract off whatever this times by this is. So we get 2x times by x squared, which is going to give us 2x cubed. Then we're going to get 2x times by minus 4x, which is going to give us minus 8x squared. Then we get 2x times by 3x, which gives us a plus 6x. And we're subtracting all of this. So now, this 2x cubed and this 2x cubed cancel. We are actually going to get a minus 8x, so that becomes 8x squared, plus, and then now we just have to subtract 3x, or subtract 6x from 3x, so we get negative 3x, plus 2. Now we have to figure out what do we have to multiply to get 8x, and the answer is just 8. So we're going to multiply the 8, so we get minus 8x squared. 8 times by negative 4 is negative 32x. And then 8 times by 3, that's just 24. Alrighty, now we have to sum it up. Or really subtract here, but the negative 8x squared and the 8x squared will cancel. We will get a negative 35x. And then we will have this negative 22. Now this right here is our remainder. So we're going to actually just say we're going to subtract off, and I'm going to factor out a negative from this. So this is just going to be 35x plus 22 divided by x squared minus 4x plus 3. Alright. So now we're going to pop this into our integral, and we're going to say we have the integral here of 2x plus 8 minus 35x plus 22 divided by x squared minus 4x plus 3 dx. Now, in theory, can we evaluate this part of the integral? And the answer is yes, but I'm not going to do it in this video. And the reason for that is it will require integration by partial fractions, which is going to be coming on later on in Chapter 7. But we can integrate this part over here. So the integral of 2x is just x squared. The integral of 8 is 8x. And we're just going to say subtract the integral of 35x plus 22 divided by x squared minus 4x plus 3 dx. Alrighty, and that is our answer for this integral-ish, other than we're not doing this part right here. Alright, now let's do another one where we can use synthetic division. So to start out, we have to solve the numerator for where it's equal to 0, or the denominator for where it's equal to 0, which is at 1. So now we can go 1. Well, with the coefficient of our highest power of x is 1. Then we have the coefficient of x cubed, which is 0. The coefficient of x squared, which is 1. The coefficient of x, which is 0. And finally, the coefficient of the constant, which is 3. Alright. Well, we drop it down. We get 1 times by 1. That is just the same thing as 1. Sum it up. We get 0 plus 1. 1. 1 times by 1 is 1. Alright. And really what you're doing is you're multiplying this number up here times by the number that you drop down and then adding it. So then we get 1. So we get 2. We get 2 times by 1, that is 2. 0 plus 2 is 2. 2 times by 1, that is 2. Plus 3 is 5. Alright. So now what we do is we can just turn this into a function. So we get x cubed plus x squared plus 2x. Alright, plus 2. Alright, and then finally we have the remainder, which is 5 divided by x minus 1. Now we can integrate this, which is going to kind of become a mess, but we will work through it. We get x to the power of 4th times by multiplied by the reciprocal plus 1/3 x cubed plus x squared plus 2x. We can integrate this final area using u sub, so we're going to say u is x minus 1. Our du then is going to be equal to dx. So it's just going to be plus 5 times by the natural logarithm of u, which is x, the absolute value of u, which is x minus 1, plus the constant of integration c. And that is our solution to this integral. So this last integral looks very scary. I suppose I could have condensed this a little. Looks like I did not. We're going to call this 6x cubed. Let's not mind that. Hopefully it doesn't give you a hint of where I got this from. I did completely create this in my head, so there's a chance this doesn't give the prettiest of results, but I think it will. So, to start out, we have the we actually can't do coefficients on this. We have to use long division. So, we have a very massive thing we have to divide here. So we're going to get x squared plus 0x plus 5. And we have to put all of this inside of here. So x to the 5th minus 2x to the 4th plus 6x cubed minus 10x squared plus 3x. Luckily, there's no constant, but we're not. That's the scary part. So we're going to say plus 0. Now we have to get to work. What do we multiply x squared by to get x cubed? The answer is x cubed. So we're going to subtract off. What's x cubed times by x squared? The answer is, and I suppose I should probably not put that right there. I should put that x cubed right over there. So we get x cubed, which is going to give us x to the 5th. We're going to get plus 0x to the fourth plus 5x cubed. And we're subtracting this off, so to start out, this x to the fifth and that x to the fifth will cancel. Or whenever we subtract them, we get 0. Then we get negative 2x to the fourth minus 0x to the fourth. So we get negative 2x to the fourth. Alright, now we have 6x cubed minus 5x cubed, which becomes just x cubed. Now we're going to just drop down this term right here, which is the 10x squared. Now what number do we multiply x by to get a negative 2 x to the fourth? And the answer is negative 2x squared. So we're going to subtract off. Let's see. So we get negative 2x squared times by x squared. So we get negative 2x to the fourth minus 0x cubed minus 10x squared. And when you look at that, something else is also going to drop out entirely right now, but we don't get to worry about that just yet. So whenever we're subtracting this is actually going to become the same thing as adding all of these terms because it's negative. So we get 0x to the fourth. We get x cubed minus 0x cubed, which is just still x cubed. And then we're going to get negative 10x plus 10x squared, which just comes out to be 0x squared. Okay. Now we have to find our next term, which we're going to drop down this 3x, so we get plus 3x. Well, what number do we have to multiply x squared by to get an x cubed? And the answer is just x. Very neat. So we're going to subtract off whatever x is times by that. So we get x cubed. X times by 0x squared is going to be 0x squared again. And then x times by 5 is going to give us plus 5x. So now we are left with x cubed minus x cubed, which is 0, plus 0x squared. And then we're subtracting, so we get negative 2x. Now we can finally drop down this last number there, which I think is a 9. So we'll say plus 9. Oh, wait, no. It's 0. Sorry, no, it's plus 0. There we go. So, now we're left with just, in theory, x squareds. And we're now going to ask, what number do we have to multiply x squared plus 0x plus 5 by to get a 0x squared? And the answer is 0. So we're going to get 0, and we're just going to subtract everything by 0. So now we're left with just a negative 2x as our remainder. So we now can write this integral as the integral of x cubed minus 2x squared plus x. We don't have to worry about the 0, but we do have a remainder of negative 2x. So negative 2x divided by x squared plus 5 dx. Well, we're going to break this down to two separate integrals. So we get x cubed minus 2x squared plus x dx minus the integral of 2x divided by x squared plus 5 dx. Now we just have to integrate this left side, which is going to give us x to the fourth times by its reciprocal, which is 1/4, minus 2/3 x cubed plus 1/2 x squared. Alright, now let's solve this right integral. So we'll say u is actually going to be x squared plus 5. So then our du is going to be equal to 2x dx. So then solving for the differential dx, we're going to get du divided by 2x. Well, this 2x and this 2x will cancel, leaving a du. This is the same thing as u, so this is just going to be the natural log of u. So we can now plug in the natural log of absolute value of u, which is x squared plus 5 plus the constant of integration c. And that is our solution to this absolute beast of an integral. I hope you all have enjoyed this video. I know one of the answers was definitely not as satisfactory as I would have liked, but I hope you all have enjoyed and found this video informative, and if you did, please make sure to like. Have a wonderful rest of your day.